2 equals negative 1 times x minus 8.
Okay, so y minus negative 2 equals negative 1 times x minus 8. Agreed? That would be point slope.
After you multiply the side with a negative 1, and then you're looking to add the 2 over the other side.
Well, actually, I think that's the issue.
That's the
Isn't
question I have.
isn't minus a negative really this?
Yeah.
So I would simplify that first before I tried to like start moving things to the other side, because otherwise you're going to have so many negative signs, right?
If you make that a positive 2, then would
Yep.
you subtract it over the other side?
You would.
Okay. That's
So, and you mentioned the whole distributing negative 1, so you get negative 1x plus 8, right?
yeah.
So then when you subtract that 2 over, that's where you're going to get that y-intercept of plus 6. Does that make sense?
Yeah.
Thank you for asking. What other things could I help you guys with here on 1, 2, 3, or 4? Okay, so our plan for the week is pretty similar to our standard plan, and that would be tomorrow and Wednesday. We'll keep practicing these same kinds of questions. Please do print the real notes off. I really sincerely apologize for I don't know, just messed up. No excuse. And happens to the worst of us too. Yes. And so I'll send you a reminder and clarify, yes, indeed, they are the correct notes now and all that stuff. So please do. And then let's see here. Oh, the other thing is 2-6. Yeah. So a lot of people have tried concept quiz retries, and all those grades are done and in, and you can go through and look. I always write a little note that says your original score was this and your retry was that, and feedback on, oh, you know what, you forgot to simplify the radical on 2b or whatever it might be, or great job, you know, you got a 95, whatever it happens to be. So please check those out. If you have yet to do a retry and you want/need to do a retry, then 2-6 is your deadline because the unit test is 2-7. I, for one, don't think it makes a whole lot of sense to take the unit test before you've mastered all the concepts. Does that make sense? So that's the goal of having that deadline on 2-6, just so that over the next roughly 2 weeks or so, you'll spend a lot of time reviewing and practicing and getting better, so that when that unit test shows up, you'll look at it and say, 3-4 weeks ago I didn't know how to do this, but I've done this so many times, I've got this down now. And the unit test is probably going to go really well. And yeah, it did. That makes sense? That's the design. I hope that makes sense to you all. You have any questions about that? All you got to do is let me know. Some of you are coming in on business lunch or some other open period or after school or whatever we need to work out, and we'll try to get that worked out. Okay, cool. So I am going to move forward. You guys are going to have a hard time moving forward because you have the wrong notes because of me. So we're going to do 3 patterns today, and I think I will do it like this. So again, find a spot in a notebook, find a spot, a blank spot in your notes. And today will be sort of an abnormal day as far as how we handle this. I am making a video of it, so if you want to go back later and kind of correlate things and be like, oh, this should have gone here, and this goes with the new notes packet and all that stuff, you can do that. All right, so let's do a little review, and then I'm going to have you guys do a little bit of thinking this morning. It says, review the parts and the meaning of exponential expressions. So, in this exponential expression right here, what do we call the x? It is a variable. It's not really a coefficient. The coefficient maybe be like 1, x to the 5th. It's the base. That's the word we use.
Witchcraft.
No, just the word base. Nothing like that. And then how about the 5? What word do we associate with the 5 in this case?
It is an exponent.
That's the exponent, yes. Okay, so the base is, in this case, the x, and then the 5 is the exponent. So I also want to review the meaning. Can anybody explain what that means? Joe?
X times itself 5 times.
That's exactly what it means. X times itself 5 times. So if I wanted to expand that out into what it really means, I would write something like that. X times X times X times X times X. I think I said it 5 times. Anyways, Okay, so this is going to be kind of the basis for our first pattern. So what I would like you guys to do is now take a look at the instructions here in numbers 1 and 2. It says, based on the meaning of what we just talked about, what exponential expressions actually mean, I would want you to think about how to simplify the following expressions and then consider your answer and try to start making some connections and some pattern recognition here, okay? So let me adjust the screen a little bit. I want you guys to think about how you'd handle numbers 1 and 2, and then I will want to hear what you did, what you were thinking, and what you got. So just take a minute or two here, consider what these really mean, and then think about how you could use that to help you simplify these expressions. And feel free to talk to each other. And I would love to hear what some of you guys think as far as what you could do to simplify these things. Any thoughts? And what I don't want to hear is, I learned this rule. We'll get around to that. Joe?
Well, x to the third means x times itself 3 times, and x to the fourth means x times itself 4 times. So if you just draw out all those x's,
Okay.
then really all you're doing is just adding the 2 exponents together.
So you're getting into a pattern now. We'll talk about that in a second. Does this make sense? Joe explained it really well. He said, hey, let's expand this into what it really is. And then when you look at it, did you guys notice that this was just x times itself a certain number of times? How many times?
Correct. 7.
So x times itself 7 times is x to the 7th. Make sense? Would you guys agree that Joe's pattern would also work on number 2? So you get x times x times x times x, and then you'd have 6 of them. There's 1, 2, 3, 4, 5, and 6 of them. And then you'd have 2 of them multiplied times themselves, right? And then you look, well, this is really similar to the definition of what an exponent is. How many x's did you count?
12.
All right, so then this gives us x to the 12th. Okay, so then let's get into Joe's pattern. Below it says, what is or what would be a more efficient way to do this? There we go. In other words, what kind of a pattern do you see? Joe, what did you see?
That if you add the exponents or add the amount, well, I'll rephrase that. Add the exponents, and then if you have one that's doesn't have an exponent, that's just 1.
Right, yeah, it's understood to be a 1, right, exactly. But you added the exponents. What did we do with the bases? Like, what happened to the x itself? It stayed the same, didn't change. Okay, so what is a more efficient way to do this? What kind of pattern did you see? It's basically this. There we go. When multiplying like bases, what did we do with the bases again? Yep. Leave the base the same. And what did you guys decide to do with the exponents? Add the exponents, yep. So you can see how seeing that pattern could be very useful when you come up against a question like, use your pattern to try. Who wants to expand that out and start counting? 1, 2, 3, 4, 5, 6. It's going to take you a long time, and even in the end, wouldn't you still be a little unsure that you might not have missed 1 or 2 of them?
Then you'd have to recount.
And then you have to retry it, and like half hour later, all you've done is one simple question that could have been done using Joe's idea of a pattern, and the rest of you seem to be nodding in agreement. So based on that pattern, what would you say this would simplify to be? So once you recognize that pattern, you can see how these get a lot easier, right? So the key takeaway is this. Here's the really math way of looking at it. See if this makes sense based on the pattern you all saw. If you have x to the a times x to the b, where a and b are just some exponents, then this would simplify to be x to the a plus b. Doesn't that go along with what you saw?
Correct.
So that would be a key takeaway for this particular skill. And for those that are interested in terminology, this is called this, the product rule. So that's just terminology stuff. I'm not really that concerned about that terminology yet. So something to think about. Okay, let's do it again. This one, similar idea, a layer of difficulty added for sure. So So again, based on what you know an exponent to be, try to write these out. Think about how it would go to simplify this all the way, and start to try to see a pattern that emerges with these two brief examples. Ready, go. So Kyrie, what would you guys say we could do with x to the third squared? Like, Callie, what is that really?
X to the third times x to the third.
That is x to the third times x to the third. Now, we can go really deep with this, or we could kind of stay right here. Based on what we just learned, what would you say the result would be?
X to the 6.
Yes, this would give me x to the sixth. Now, like I said, you could go deeper. Couldn't you say that x to the third is really x times itself 3 times, and x to the third is x times itself 3 times, and then x times itself 6 times is really x to the sixth?
Yes.
So you could have gone a little deeper and done something like that. Either way, I'm okay. I want to make sure you understand what's happening here. Couldn't we do the same thing with the other one?
Yes.
What's x to the fourth to the third? Yep, we got 3 of them being multiplied together. So just like we did a minute ago, we could then say, hey, look, when you're multiplying those bases, the pattern we saw is that you add your exponents. This would give us x to the 12. So does anybody see a pattern emerging that we could use to help us when the numbers get big, complicated, something like that? Joe, what is it?
Just multiply the exponents together.
There it is. So let's make sure we understand the conditions that lead us to that. So if you think about what we use to see that pattern, if you have, I'll say it like this, for a power raised to a power, does that make sense? Like x to the 3 to the 2. X to the 4 to the 3. So if you have a power raised to a power, what did we do with the bases? Yep, leave the base the same. And what do you do with your exponents? And it's multiply. That's right. Right, 2 times 3 was 6. 4 times 3 was 12. So we would multiply our exponents like so. All right, so then a key takeaway we will arrive at here in just a second. But what pattern, or how would you use the pattern for, and you got to admit, if we tried to write that one out, we'd have to write out x to the 9th times itself 8 times. And if we went deeper than that, we'd have to write out x to the 9th as x times itself 9 times, and then do that 8 times, right? So you can see how a pattern would be nice, if you could see the pattern. So if I tried to use my pattern, what would I get?
X to the 72nd.
So when you think about how much of a pain that would be to write that out, you can see why the pattern is a very good thing. And we're not even talking about, I mean, you could do questions like this if you wanted to.
Oh, God.
Right? Can you imagine how hard that would be to do like the old slow way versus, hey, as long as I could just use my calculator real quick and multiply those two exponents together, I'd be done, right? So please consider this key takeaway. If you have a power, like x to the a, raised to another power, like x to the a to the b, what do you do with your exponents? You multiply them, x to the a times b. This is called power rule in your book. Again, I'm not super hung up on, did you memorize the name of the rule? I mean, I'll refer to them as such. I just want to make sure you understand why these relationships and connections work versus I memorized a rule, because that always falls apart eventually. Anyways. Okay. Last one, unless you have a question. Okay, cool. So here it is. Once again, based on all this meaning of exponents and things like that, let's think about how these would work. Okay? So write them out as needed. Consider what pattern emerges for you.
Big money.
We'll check back.
That's spot 20.
Okay, what could we do here to start to see a pattern? What could I do? What could I do with x to the 5th? Hey, guys, I'm approaching this from the perspective of, what if I was like, I knew the real basics about exponents, but I was kind of clueless about everything else, right? What could I do with x to the 5th to help me understand the pattern that needs to emerge? Well, okay, I'll keep the base the same, but I need to like expand it, right? That's right. We're going to do this a bunch of times here, so it'd be x times itself 5 times, because I know that that's what an exponential expression actually means. Of course, I could do the exact same thing with the denominator, except it's a little easier. X times x. And Kyrie's doing this whole, and I think I know what's she trying to tell us? No, I don't think she's saying that. She's saying let's do some canceling out, which we've done before, right? Since we're doing multiplication over multiplication, couldn't I cancel this x with this x? The x over x is 1, right? And I could cancel this one with this one, because x over x is 1. You with me? What's left over?
I just figured it out.
X to the
Third.
right? X times itself 3 times. Okay. So then this other one, this would be x times itself 9 times. 6, 7, 8, 9.
We've got the same brain.
Hey guys, let's wrap this up well. Okay? So if you expanded out the second one the same way, do you see how there would be a cancellation again? So wouldn't maybe this one cancel with that one?
Yes.
Leaving me with how many x's being multiplied together? 8 of them. So this would be x to the 8th. What pattern did you see show up here? Yeah, whenever you're dividing like bases, you end up subtracting your exponents, leaving the bases the same. And guys, it's really important for you to understand this. Please don't pack up yet. I still have 3 whole minutes, or 2.5 at least. The subtraction pattern, it's not important with addition, right? Because isn't 2 plus 8 the same thing as 8 plus 2? The subtraction, it's really important you get the order right, because 2 minus 8 and 8 minus 2 are different numbers. And so the way that you subtract here is you subtract the numerator's exponent minus the denominator's exponent. Okay, so that's the pattern. So whenever you're dividing like bases, leave the base the same and subtract exponents, and I'll put top minus bottom. Does that make sense? Numerator's exponent minus denominator's exponent. So can you see how use your pattern to try? You see how that would be unspeakably difficult if you had to expand that thing out and start canceling. You'd have to cancel out. It'd take you a long, long time. Again, even then, there's so many of them, you probably doubt yourself and think, oh, I probably messed up somewhere. If you use your pattern here, what do you get? You'd subtract numerator exponent minus denominator exponent, and you would get x to the 6th. Here's your key takeaway. If I have x to the a over x to the b, I get x to the a minus b. This is called, anybody want to venture a guess? If you're dividing, it's called a quotient. So this is...
Devotion. Did you say devotion?
I didn't say devotion.
No, he said quotient. He used a good word. Okay, guys, so that's it. Tomorrow, perhaps we'll have a regular day, and I will hope to see you then. Have a great day.
I almost